Hey folks, in this video we are going to solve a problem on Fibonacci series. Fibonacci, you can pronounce in any way, but it will always remain same. Fibonacci series using recursion. Okay, what is the Fibonacci series? Fibonacci sequence or series. Fibonacci sequence is a series of numbers where a number is the addition of the last two numbers starting from 0 and 1. So basically, it is an example of Fibonacci sequence. It starts with 0 and 1. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 3 is 8. 8 plus 5 is 13. In this way, this series goes on. We have to find the Fibonacci series sum formula. So basically, we will add the fn minus 1 plus fn minus 2. So basically, suppose the value of n is 2. So 2 minus 1 is 1, that is this index, and 2 minus 2, that is 0th index, that is this. So 0 plus 1 is 1. In this way, we can find the sum of Fibonacci sequence. Okay, so let's code into the VS Code. So we are in the coding window now. So we will write the definition of the Fibonacci function using recursion. Fabo. I will remain it FIB. It is being Fabo and Fibonacci. Okay, so we have to return the recursive function n minus 1 plus recursive function Fibonacci n minus 2. So we have to call it using some print Fibonacci, suppose 5. Maximum recursion depth exceeded. It means we have not given the base condition and the program goes into the infinite loop. So let's mention the base condition. So let's see what is the base condition. So the base condition is if n in 0 and 1, so return n. So if the recursion limit is crossed and if value of n is 0 and 1, then we have to return the r. So let's code it into the VS Code. So yeah, let's code the base condition. The base condition is if n in 0, 1, 0, 1, then we have to return n, else return the logic. Okay, this is the logic. Okay, let's save it and run it. Okay, the answer is 13. So the seventh element is 13. Let's check. This is 0, 1, 2, 3, 4, 5, 6, 7. Yeah, the program is working fine. But instead of writing 7, if I write minus 7, then what will happen? The recursion, maximum recursion depth exceeding. So that we have to also implement the hidden cases. Let's see the hidden cases. So yeah, let's see the hidden cases. The n should be greater than or equals to 0, and the number should be integer. So let's code it. Yeah, so let's implement the uh, hidden cases of the Fibonacci question. So basically we will use assert function and n should be greater than or equals to 0, and number should be integer. N is equals to n. Number we have to write in the body. Fibonacci number can only be positive integer only. Okay, let's run this code for 6. So it is giving 8. Yes, this is the right answer. 0, 1, 2, 3, 4, 5, 6. The answer is 8. Yeah, so let's run it for -6. It will show error. Fibonacci number can only be positive integer. Okay. If we write 9.9, so what will happen? Yeah, Fibonacci number can only be positive integer.